Okay, class. There's a PowerPoint I have called Electrophysiology of Muscle that you'll see in the A&P2 section. Now, this particular PowerPoint is quite heavy because normally I'm teaching face-to-face. So I can explain it. Basically, we're looking at heart action. I'm going to say in this particular PowerPoint, and maybe a little difficult for you to get through this one, and so I'm showing 4 different action potentials. This would be the one, the neuron action potential you studied in A&P1. This would be a skeletal muscle you studied in A&P1. What I did was to come in to show you the comparison between this and the heart ones, which is this and this. Now, I even went in and tried to write out the events in a neuron action potential. I'm not going to go through all that because I took my time to write that out, and you can study that for those that really can get into it. I spent a lot of time putting all of this together in order to show you everything. And then to compare and contrast it as we get further down, there's a neuron action potential as to, so we're looking at what we'll call excitation, contraction, coupling. Excitation, contraction. That see in muscle, you have excitation which leads to contraction. They must be coupled. In the heart, that's really important. The EKG, which we'll speak briefly about, not in this video, looks at excitation. Contraction, if we do it non-invasive, that means without going inside, would be looked at by an echocardiogram. So we have excitation, contraction, coupling. I wanted to show you the various things that we do. So I want you to go through on your own and try to understand this. Now, if this PowerPoint is too hard, then use the textbook. If this PowerPoint is too hard, then use the textbook, because I went into a lot of detail here, and it's a little hard to explain without being face-to-face. So what I did was, here's what you're trying to derive, whether you use this here or whether you use the textbook. What you want to come away with are my take-home points. Okay, these are, and I should have said my, I don't know why I put make take-home points. There you are, my take-home points. Okay. One is the heart has 2 types of action potentials. It has the cardiac muscle action potentials and the pacemaker potential. The cardiac muscle action potential and the pacemaker potential. The cardiac muscle action potentials have an extended absolute refractory period. Now in here, let me see if I can find it. This is an explanation of the absolute refractory period, so at least you can get that part. This extended absolute refractory period prevents tetany. Tetany is a sustained contraction. You do not want the heart to go into tetany. You do want your skeletal muscles to do that. Because that's the only way, if you go and study it, that's the only way you can hold tension. Continuous tension. But you don't want the heart to go into that. A tetanic contraction of a chamber would not allow it to fill. Remember, a chamber must be a diastole to fill. If it cannot fill, it has nothing to empty. So this prolonged absolute refractory period, whether you study it in my PowerPoints or you look at it in the textbook, prevents the cardiac muscle from going tetanic. If it does, that's what we call atrial fibrillation and atrial flutter. Unfortunately, I can't discuss that without face-to-face, so this semester I won't. But it can go wrong, but that's the purpose of that. All right. Now, The pacemaker potentials here have autorhythmicity. That this overshoot right here, if you want to read in my deal, this overshoot, this hyperpolarization right there, causes the opening of slow sodium channels. And you can read on that. So they have an automatic rhythm. Now, the speed of the automatic rhythm varies because the SA node, the speed is much faster. So it reaches threshold much faster. That gave it, that's why it's called the natural pacemaker of the heart. So these points here are my take-home points, which you would, if you go through the book, and don't use this, because for some this may be too detailed, then that would give you a good idea of what I'm speaking of. The textbook does a pretty good job on that. I may even have a video on this here. All right. So I'm going to close here, and in this particular video here.